This is solutions to homework number 3. So you were supposed to look at the following statement, which is not quite true, and see what's wrong with it. So the first thing was you were supposed to give a counterexample. Most of you didn't have trouble with that, just find some negative numbers. The next thing was to say, well, without looking at the proof, how do you know the proof has to be wrong? And the answer was, there exists a counterexample, thus the proof must be wrong. And here's the proof that you were supposed to analyze. Take 4 real numbers, suppose that u is less than v and w is less than x, multiply the inequality on both sides by something to get an inequality, multiply this inequality on both sides by something to get an inequality here. Then you have these two inequalities which you can put together with the transitive property showing that uw is less than vx. So, what's wrong with this picture? So, what specific mistakes exist in the proof? Well, according to the working definitions, in order to multiply an inequality with something, it has to be something that's bigger than 0. And so that is, in fact, the specific mistake, is that we didn't assume that this w was bigger than 0 before we multiplied it by the inequality u less than v to obtain uw less than vw. And similarly, when multiplying the inequality w less than x by v, we didn't first require that v is bigger than 0. So therefore, the minimal change that should be made is to assume that v and w are both bigger than 0, and then the formal statement looks like this. Now, some of you made other changes, which also kind of worked. They're minimal in a sense that you didn't have to change as many symbols. Some of you said change the real numbers to natural numbers, or just the positive real numbers, assume that all of u, v, w, and x are positive. But that's not actually minimal in terms of the what you need to assume, because in particular this thing works even if u is negative as long as all the other 3 are positive. So, anyway, just to let you know. Now the other problem was to prove by contradiction that if a plus b is even, then a minus b is even. Well, if you want to prove something by contradiction, you have to assume that it's false and then get a contradiction. So the useful denial is that there exists an a, b, and z such that a plus b is even and a minus b is odd. Now there are actually several correct ways to do this proof. I saw a bunch of good stuff and some not good stuff. Let me show you one way to prove this, but there really were several ways. Some people went case by case. Case by case is just fine here. However, here's what I did, and what several of you also did. So suppose that there exist integers a and b with a plus b even and a minus b odd. Then, okay, a plus b is even, so it's equal to 2k for some integer k, and a minus b equals 2j plus 1 for some integer j, using the working definitions of even and odd. Then we can add these two equations to each other. So the left-hand side, a plus b plus a minus b is 2a, but then on the right-hand side, that's 2k plus 2j plus 1, which you can use the distributive property to factor out a 2, and now you have an odd number equaling an even number. It's a contradiction because no integer is both odd and even, and hence the useful denial over here is false, so the original statement must be true. Toodaloo.